Good morning. So here the problem is, by means of the Dft and Idft, determine the response of the FIR filter. Determine the FIR filter response with impulse response h of n is equal to 1, 2, 3 to the input response x of n is equal to 1, 2, 2, 1. Right. So here to solve this problem, so that means here given is FIR filter with response h of n, input is x of n, determine filter output response. What is that? Here let it be y of n. So usually here to determine this y of n, so from the knowledge of x of n and h of n, so we have the different approaches, right? The first one is in the time domain, convolving x of n and h of n to get the y of n. So here use the linear convolution methods, then you can get the y of n from x of n and h of n. So here, but here in the question they specified what is that? Use Dft and Idft approach. So here we know that Dft y of n is nothing but x of n circularly convolution with h of n. But to find out the filter output, use only the linear convolution. That means here in Dft and Idft actually, so you have one method. What is that? Circular convolution between these two, you can get the y of n. And then in Dft, so we have one property. What is that? Circular convolution property. From that, from the circular convolution property, this is nothing but Dft of y of n is y of k. Dft of x of n circularly convolved with h of n is nothing but x of k into h of k. So right, so first determine, so Dft of x of n, then Dft of h of n, then multiply these two, then you can get the y of k. Then do the here Idft, inverse Dft on this particular y of k, then you can get the y of n. So this is the approach here. So but here, so we should not use this circular convolution, so we have to use the linear convolution. That means here, so use the circular convolution, right, to get the linear convolution output. So we follow like that. Okay, that means here see circular convolution result, obtain, right, circular convolution result, right. So obtain, but that should be equal to linear convolution result. Okay, right. So both should be same. So in what way here? So listen here. Here is take x of n. What is the length here? What is the length of x of n? Let it be L. What is the length of h of n? M. And let it be length of y of n is n. So here actually in linear convolution this length is equal to L plus m minus 1. In circular convolution the length is equal to maximum of L comma m. So that means here to get the linear convolution result, do the circular convolution to achieve the n as equal to this one. What is that? L plus m minus 1. That means here do the zero padding. Do the zero padding to the x of n and h of n to reach n is equal to L plus m minus 1, and then perform circular convolution between x of n and h of n. Perform circular convolution between x of n and h of n. Then you can get the linear filter output. Linear filter output. Okay. So this is the one here. If they are asked like that, find the filter output only, not mentioning the Dft and Idft approach. So you just take x of n and h of n and convert these lengths according to L plus m minus 1 by applying zero padding. Then perform circular convolution methods. So either matrix multiplication method or concentric circle method. Then you can get the, what is that? Output. Okay, right. Now circular convolution result is equal to linear convolution result. Okay, but now here the case is, use the Dft and Idft approach. So Dft and Idft approach means it consists of step 1. What is that step 1? To find the output here, linear filtering output. Linear filter output using Dft and Idft. The first step is perform zero padding. Zero padding to input and filter impulse response. Right? So here to reach n is equal to L plus m minus 1. To reach n is equal to L plus m minus 1 length. So then apply the zero padding to the x of n and h of n. Step 2. Here find Dft of x of n. Let it be x of k. Step 3. That to endpoint Dft. Next find endpoint Dft of h of n. Let it be h of k. Step 4. Multiply this x of k and h of k, that is equal to y of k. Step 5. Find Idft, that one also endpoint, Idft of y of k. This is nothing but y of n, which is the required result. Filter output response. Okay, right? So these are the steps here. So we should follow. So now here first step 1. What is that? Step 1. zero padding. So zero padding means here first find the n. N is equal to L plus M minus 1. Here x of n is 1, 2, 2, 1. H of n is 1, 2, 3. Now x of n length is 4. H of n length is 3. Now you can get the answer 7 minus 1, 6. So now here pad with the zeros here. Take x of n. Here only length is 4, but we should get the length n, 6. That means add 2 zeros here. Now you can get the length 6. Next take h of n. That is 1, 2, 3. So now take 3 zeros. Then you can get the length 6. Okay, right. Like this. First change the sequence like this. So now if you count this one, if you take length of the particular, what is that, x of n and h of n. So what is that? That is the 6. That means here to find out the x of k and h of k, you may use greater than or equal to 6 point DFTs. So okay, right? So you can use this one. So greater than or equal to 6 point DFTs. So here if you may use what is that butterfly diagram here. So that means we have the 4 point, 8 point, 16 point butterfly diagrams. That means here 6 point DFT means you may use the 8 point what is that, a DFT. So that means take the butterfly diagram, 8 point DFT, D8, either D8 FFT or DIF FFT. By using that one also you can simply find out the x of k and h of k. Okay. But here we are in unit 1, so we cannot use the what is that butterfly diagram actually. So we have to use the direct method. What is that? From the definition, basic formula, we have to find out the DFTs. Okay. So now here I am taking only 6 point DFT. Here also you may take what is that 8 point DFT. Okay. But here I am using 6 point DFT. Okay, right? To know how to solve this one 6 point DFT rather than 4 point, 8 point like that. So we have to know that one also. That's why here I am using 6 point DFT. Now what is the second point here? To find out the x of k. So now perform 6 point DFT. 6 point DFT of x of n is x of k. Okay. Right. So now x of k is equal to summation, basic formula, this one. So we know that omega n power kn or e power minus j 2 pi n k by capital N. Okay. Here k value is 0 to n minus 1. Okay. Here substitute n is equal to 6. So now x of k is equal to summation n0 to 5 x of n w 6 power kn. Here k range is 0 to 5. So now first expand this one. X of k is equal to x of 0 plus x of 1 w 6 power 1 x of 2 w 6 power 2 k x of 3 w 6 power 3 k x of 4 w 6 power 4 k x of 5 w 6 power 5 k. Right. So now here what is the x of n here? Given 1 2 2 1 0 0. Okay. So now here, so apply all these values. X of 0 is 1, x of 1 is 2, next x of 2 is 2, x of 3 is 1, and remaining zeros. Now this is x of k. So here k is 0 to 5. So take this formula and then determine the what is that x of k values. Okay, right? So now here first one, x of 0. X of 0. See that? One plus 2. W6 power 0 means 1. W6 power 0 means 1. W6 power 0 means 1. Okay, right. So now if you apply k0, so all total factors power 0 gives the 1 value. 2 plus 2, 4 plus 1, 5 plus 1, 6. Next, x of 1. What is x of 1? 1 plus 2, W6 power 1, 2, W6 power 2 plus W6 power 3. Now here we have to substitute these values. Now consider this. What is the W6 or Wn? E power minus j 2 pi by n. Okay, right? That means e power minus j 2 pi by 6. Here n is equal to 6. That means e power minus j pi by 3. Okay, right. So now substitute W6 power 1 means e power minus j pi by 3. What is that? Cos pi by 3 minus j sin pi by 3. Cos pi by 3 is 1 by 2 minus j sin pi by 3 is root 3 by 2. Okay, that means W6 power 1 is 1 minus j root 3 by 2. Similarly, W6 power 2 is e power minus j pi by 3 whole square. That means 2 pi by 3. Cos 2 pi by 3 minus j sin 2 pi by 3. That is minus 1 by 2 minus j root 3 by 2. So that means here that is minus 1 minus j root 3 by 2. Similarly, W6 power 3 e power minus j 3 pi by 3. That means minus j pi. Right? So e power minus j pi is nothing but minus 1. Cos pi minus j sin pi. That is minus 1. Okay. So in this way you just find out, right? So otherwise you may take W6 power 3 is nothing but like this. W6 power from the symmetry property. What is that? 6 plus 6 by 2. N by 2. W6 power small n plus capital N by 2 is equal to minus W6 power n, like that. Here which gives W6 power 0 plus 3, that means the minus W6 power 0, which gives the value minus 1. Okay, right. So you may use any method. Okay, right? It's okay. Now this one is equal to, what is that? 1 plus 2, 1 minus j root 3 by 2 plus 2 minus 1 minus j root 3 by 2 plus here is a minus 1. Now here the answer is, right? So see this. So 1 minus 1 gets cancelled, 2 gets cancelled. Now 1 minus j root 3 minus 1 minus j root 3. Okay. So now here you can get 1 minus 1 gets cancelled, minus j 2 root 3. This is x of 1. Okay. Similarly, x of 2. So here x of 2 is here. So here apply in the k 2, right? So now 1 plus 2 omega 6 2, then 2 w6 power 4 w6 power 6. So now here, so we have the values, right? w6 power 2 also. Oh, what is that? 1 plus 2. w6 power 2 is nothing but minus 1 minus j root 3 by 2 plus 2. w6 power 4 means here we may write like this. What is that? w6 power 1 plus 6 by 2. That means minus w6 power 1. What is the w6 power 1 here? That is minus of w6 power 1 is 1 by 2 minus j root 3 by 2. That's why. So minus 1 plus j root 3. Okay, it's okay. This one. Am I correct? Now plus w6 power 6. w6 power 6 means w6 0 plus 6. From this linearity property, w6 power 0. What is that? 1 value. Okay, right. So now here 1 plus 1 2, 2 cancel, 2 cancel. Now here is minus 1 minus j root 3. Here minus 1 plus j root 3. Now the answer is here 0. This one gets cancelled. Minus 2 plus 2 0. Then x of 2 0. Now x of 3. Same thing. 1 plus 2 w6 power 3. 2 w6 power 6. w6 power 9. So now, so here take 1 plus 2. What is the w6 power 3? Minus 1. Okay. So similarly, w6 power 6 means w6 power. So what is that? 1. Next one, w6 power 9 means w6 power 9 means 3 plus 6. w6 power 3 minus 1. Okay, right. So very simple. From the knowledge of very few twiddle factors, we can find out the all other twiddle factor values. Okay, here minus 1 plus 2, 1, here minus 1. Now 1 minus 2 plus 2 minus 1. What is the answer here? 0. X of 4. 1 plus 2 wx power 4. 2 w6 power 8. w6 power 12. So now see this. 1 plus 2. w6 power 4 means here. What is that? This one. w6 power 4. Am I correct? 1 plus 3. So now here minus 1 minus j root 3 by 2 plus 2 w6 power 8. w6 power 8 means w6 power 2 plus 6, that is equal to w6 power 2. What is the w6 power 2? Minus 1 minus j root 3 by 2 plus w6 power 12. 12 means w6 power 2 into 6 plus 0. w6 power 0 means 1. So now that is 1. So now here also if you simplify this one, okay, 1 plus 1 2. Here is a minus 1 minus 2 gets cancelled, plus j root 3 minus j root 3, you can get the value 0. Okay, right. So now coming to the last value, what is that? X of 5. X of 5 is equal to 1 plus 2 w6 power 5, 2 w6 power 10 plus w6 power 15. Now 1 plus 2, what is the w6 power 5? w6 power 2 plus 6 by 2, w6 power 2, right? So what is the w6 power 2 here? Minus w6 power 2 is minus 1 minus j root 3 by 2 plus 2 w6 power 10. w6 power 10 means w6 power 4 plus 6. w6 power 4. What is the w6 power 4? Minus 1 plus j root 3 by 2. Plus w6 power 15 means w6 power 2 into 6, 12 plus 3. That means w6 power 3. Right? So w6 power 3 means minus 1. So here, based on linearity and symmetry properties of dual factors, we can compute easily, right? So now 1 minus 1 cancel. Now here plus 1 plus j root 3. Here plus j root 3 minus 1. Minus 1 minus cancel. So now we can get j 2 root 3. Now what is the x of k here? First value is 6. Second value is minus j root 3, 2 root 3, then 0, 0, 0. Now j 2 root 3, right? So in this way, we just computed x of k from x of n. Now next one is, what is the second step, third step here? 6-point Dft computation again for the sequence h of n. It is said to be h of k. Now here h of k, what is the formula here? Summation n0 to n minus 1 means 5. Here is h of n w6 power kn. Here k range is 0 to 5. 0 to 5. So now h of k is equal to h of 0 plus h of 1 plus h of 2 h of 3 w6 power 3k, h of 4 w6 power 4k, h of 5 w6 power 5k. And of course the given h of n is equal to, what is that? 1, 2, 3, 0, 0, 0. So now here see this, h of k is equal to 1 plus 2 w6 power k plus 3 w6 power 2k. Remaining values zeros, right? Now here k value is from 0 to 5. 0 to 5. So now find the values here. What is that? H of 0. H of 0 is equal to 1 plus 2 plus 3, 6. What is the h of 1 here? 1 plus 2 w6 power 1, 3 w6 power 2. So here just substitute the values. So already found. So in the previous slide. Okay, what is the w6 power 1? 1 minus j root 3 by 2. Then plus 3 into w6 power 2 means minus 1 minus j root 3 by 2. Now here, so simplify this one and then you can get the value like 1 minus j 5 root 3 by 2. Okay, similarly take h of 2. H of 2 is 1 plus 2 w6 power 2, 3 w6 power 4. So here also 1 plus 2, what is the one? w6 power 2? Minus 1 minus j root 3 by 2 plus 3. w6 power 4 is minus 1 plus j root 3 by 2. Right, now after simplification you can get minus 3 plus j root 3 by 2. Now similarly h of 3. H of 3 is nothing but here, what is that? 1 plus 2 w6 power 3 plus 3 w6 power 6. Now 1 plus 2 w6 power 3 is minus 1. w6 power 0, w6 power 6 means w6 power 0. What is the value? 1. Now, so simplify and then you can get 2. 1 minus 2 plus 3. Now, h of 4. 1 plus 2 w6 power 4 plus 3 w6 power 8. Now, this is equal to 1 plus 2. w6 power 4 means w6 power 1 plus 3 minus w6 power 1. What is the value here? Minus w6 power 1 means minus 1 by 2 plus j root 3 by 2. Right? Minus 1 plus j root 3 by 2 plus 3 into w6 power 8 means w6 power 2 plus 6. That means w6 power 2. So, what is the w6 power 2? Minus 1 minus j root 3 by 2. Right? So, now simplify this one and then you can get what is that? Minus 3 minus j root 3 by 2. Now, h of 5, last value h of 5, that is equal to 1 plus 2 w6 power 5 plus 3 w6 power 10. Now, that is equal to 1 plus 2. What is the w6 power 5? w6 power 2 plus 3. That means minus w6 power 2. So, now that is nothing but 1 plus j root 3 by 2 plus 3. What is the w6 power 10? w6 power 4 plus 6. That means w6 power 4. That is nothing but minus 1 by 2 plus j root 3 by 2. Now, simplify, then you can get the value like this. 1 plus j 5 root 3 by 2. Okay. So, now finally write the sequence here for h of k. What is that? That is nothing but 6 comma 1 minus j 5 root 3 by 2 comma minus 3 plus j root 3 by 2 comma 2 comma minus 3 minus j root 3 by 2, then 1 plus j 5 root 3 by 2. Okay. So, now, so this is h of k and then this is nothing but x of k. So, now what is the next step here? Step 4. Step 4 is multiplication. That means achieve y of k based on this multiplication between x of k and h of k. So, here take x of k and h of k, then you can get the, what is that? Y of k value. Right? So, now here x of k is 6 comma 1 minus j 5 root 3 by 2 minus 3 plus j root 3 by 2, 2 minus 3 minus j root 3 by 2, 1 plus j 5 root 3 by 2, which is multiplied with 6 minus j 2 root 3, 0 comma 0 0, then j 2 root 3. So, multiplication means at each sample you just multiply the amplitude value, okay, corresponding values, right? That means 6 6 36, at n 0 6, here 6, then 6 6 36, and then at n 1 here is the value this one, here is the value this one, and multiply and then you can get the answer like this, minus 15 minus j root 3, then 0 into anything 0, next last value j 2 root 3 into 1 plus j 5 root 3 by 2, then you can get the answer minus 15 j root 3. This is nothing but y of k. After completing the y of k, so next step, what is that? To determine y of n here, apply again 6-point IDFT, inverse DFT to this y of k. Okay, right. So, now here to determine this y of n, what is the formula? 1 by n y of k wn power minus nk. Here this is k 0 to n minus 1. N range is 0 to n minus 1. Now for n6 value 1 by 6 summation k 0 to 5 y of k w6 power minus nk, and n range is 0 to 5. So now here just simply take here, or is that you know the total factor values but power plus that means plus values. So like here see this one, right, w6 power kn like that, but here we have w6 power minus nk. So very simple one, w n is equal to n power nk is equal to wn power minus nk. Okay, right? So here wn power minus nk is achieved by complex conjugation of this wn power nk, right? So here take wn power nk values, do the complex conjugation, then you can get the wn power minus nk values. Okay, right? So now here based on that, and then first what is the regular method, take y of n. So with the expansion of this summation, now y of 0 plus y of 1 minus n, right, plus y of 2 w6 power minus 2n, y of 3 w6 power minus 3n, y of 4 w6 power minus 4n, y of 5 w6 power minus 5n. Now here substitute y of k values here. What is that? Y of n is equal to 1 by 6. What is the y of 0? 36. Y of 1 minus 15 minus j root 3 w6 power minus n. Y of 2 0, y of 3 0, y of 4 0, right? So 0 into anything 0. Next y of 5. What is the y of 5? Minus 15 plus j root 3. This one is w6 power minus 5n. Now here n value 0 to 5. So here you just complete this one for the, what is that, n 0 to 5. So here it's okay. Here substitute n 0 here. What is that? Y of 0. Y of 0 is equal to, so what is the y of 0 here? 1 by 6, 36 minus 15 minus j root 3. So anything power 0 means here 1 into 1. Next one plus minus 15 plus j root 3 into w6 power 0, that means 1. Now you can get here the values 36 minus 30, 6 by 6, 1, right? So y of 0 is 1. Similarly y of 1. What is the y of 1 here? 1 by 6, 36 plus minus 15 minus j root 3 w6 power minus 1 plus minus 15 plus j root 3 w6 power minus 5. So now this is equal to what is the w6 power minus 1? w6 power 1 complex conjugation. So that means here my 1 by 2, what is the w6 power 1? 1 by 2 minus j root 3 by 2, that means 1 by 2 here minus j root 3 by 2 whole complex conjugation. So here that means 1 by 2 plus j root 3 by 2. So now substitute that value here. Okay, now w6 power minus 5 also, w6 power 5 complex conjugation. So now 1 by 6, 36 plus minus 15 minus j root 3, 1 plus j root 3 by 2 plus minus 15 j root 3. w6 power minus 5 means w6 power 5 complex conjugation, that is 1 minus j root 3 by 2. Okay, now after simplification here you can get the value 4. Okay, so in this just find the y of 2, y of 3, y of 4, y of 5. So y of 2 is nothing but here so you can get 11, y of 3 as 11, y of 2 is 9, y of 4 is nothing but 8, y of 5 is nothing but 3. So in the same way determine, so then you can get the answers like this. So here y of n is nothing but 1, 4, 9, 11, 8, 3. So for the given x of n and h of n, the output is this one. Okay, right? So if you perform what is that circular convolution without zero padding, which is equal to the linear convolved output, then you can get only the here what is the maximum of L comma M, 4. So you can get only 4 values only. But here we are using what is that circular convolution, but to reach the linear convolution output by padding the what is that zeros, which is equal to n L plus M minus 1. So this is the method using DFT and IDFT method. And of course if they are asking like what is that, perform the circular convolution and find the linear filter output, then so here what we can do, so use the circular convolution method, but zero padding is done by what is that n value L plus M minus 1. Okay, so that means here or alternate method, so using circular convolution, so here take x of n is what is that 1, 2, 2, 1. So add the zeros, okay, according to linear convolution result, right? Now what is the h of n? 1, 2, 3, 0, 0, 0. Now here use the concentric circle method or matrix multiplication method. So if I use matrix multiplication method here, so now take the here you can get the output. Okay, right? So what is that? First here note down h of n here 1, 2, 3, 0, 0, 0. Here is 1, 2, 2, 1, 0, 0. Now write 0, next 1, 2, 2, 1, 0. Here write 0, 1, 0, 1, 2, 2, 1. Here write 1, 0, 0, 1, 2, 2. Here write 2. Next one 1, 0, 0, 1, 2. Here write 2, 2, 1, 0, 0, 1. Okay, right? So then you can get the output. What is that? So do the matrix multiplication here. So 1 into 1. What is that? 1. So remaining zeros. Now here is the 1. This is nothing but what is that? Y of n. So next one is 2 into 1, 2. Next one plus 2. So now here in this way you can check the result here. Okay, right? So this shortcut method. So here in this way you can validate your output, right? So in the DFT IDFT method we have found one value y of n. So we just validate that one by using this particular method, matrix multiplication method. Okay, 2 ones are 2 plus 2. What is that? 4. Next one, 2 ones are 2, 2 twos are 4, 3 ones are 3, remaining zeros. That means 2 plus 4 plus 3, 9. next one 1 1 1, next one 2 3 plus 2 3s are 6, that means 6 plus 6 plus 4 10 plus 1 11. Next one 0 1 2s are 2, 2 3s are 6, that means 8. Next one 0 0 1 3s are 3, remaining zeros, right? So in this way just find out 1 4 9 11 8 3. Okay, right. So here actually if they ask normally determine circular convolution means between two sequences, not asking like linear filter output like that, then here you just pad the what is that we are using zero padding, so only based on maximum of L comma M, so then you can get the different answer. Okay, right? So here don't confuse. So exam lo manaki just వాళ్ళు అడిగిన దాన్ని బట్టి do the circular convolution means you just directly take the what is that maximum of L comma M based. Otherwise if they ask the filter output like that, we have to perform linear convolution method. That's why here use here linear convolution result, what is the n value, like that you just pad the zeros according to that n value, that is L plus M minus 1. That only difference here. Okay, this is the one here linear convolution results based on circular convolution methods. So one is the direct method, what is that matrix multiplication or concentric circle method, or you may use the Dft and Idft approach, like what is that, so already discussed. Now first one take zero padding according to linear convolution result. Next one is the find the Dft of x of n and find the Dft of h of n. Next multiply x of k h of k, then Idft of y of k, that is the y of n. Okay, thank you.